Okay, today we are going to be simplifying radicals. This is my presentation for Monday, April 29th. First of all, let's go over the parts of a radical. A radical is the symbol that's taking the square root of a number. The number is called the radicand. It's not a Pokemon, it's called a radicand. It's the value you're taking the square root of. The index is usually 2 for square roots. If it's any other number, it's a cube root for 3 or fourth root or fifth root. That's what the index is. The coefficient is the number in front of the radical. Usually it's 1. If it's not, you multiply by it. How to simplify radicals? Well, when you're done, it's simplified when the radicand has no perfect square factors except for 1, like 5. 5 is prime, or it's not a perfect square, so you're done. There's no fractions, which means there's no radical on the denominator of the fraction, like square root of 6 over 2. It doesn't equal the square root of 3. It's a completely different number, but you can't simplify it anymore. We're going to go over problem 1. You're going to have to go back to 6th grade when you made factor trees for prime factorization. So, for the square root of 160, we're going to simplify it using a factor tree. Square root of 160 can be broken down into 16 and 10. You can do other numbers, but this is what I'm going to do. Then you break down 16 and 10 more. 16 can break down to 4 and 4. 10 can break down to 5 and 2. I'm going to stop there. You could do 4 and 4 as 2 and 2 twice, but you don't really need to. I see 2 4s. When you have prime numbers only, you circle the 2 4s. That number goes on the outside of the radical once. 5 and 2 will go on the inside, and you'll remultiply them. So our final answer is going to be 4 radical 10, because you multiply 5 and 2 on the inside, and the 4 is pulled out once for the outside. Now we're going to go over a problem with the coefficient. 3 times the square root of 108. We're going to use our factor tree to break down 108. I'm going to start with 12 and 9. 12 can be broken down to 4 and 3. 9 can be 3 and 3. 4 we could break down into 2 and 2. I circled the 3 and the 3 because it's there twice. And as a result, we have a 1, 3 left over that I've underlined. That will stay on the inside. 2 and 3 will go on the outside of the radical, but we have to multiply those by the first 3 on the outside. So it's going to be 3 times 3 times 2 on the outside, and square root of 3 on the inside. 18 square root of 3 is the final answer. Here's 3 practice problems for you to try. Square root of 24, square root of 12, square root of 72. I'll let you work on those and then we'll go over the answers. Now that we're back, here's the answers. The first one is 2 square root of 6 because 24 breaks down to 4 and 6. 4 is a perfect square of 2 and 2. Square root of 12 is 2 square root of 3, or 2 radical 3. 4 and 3 make 12. Square root of 4 is 2. And the last one, you have to break it down. The perfect square in there is 36, which is 6 and 6, and 2. 2 stays on the inside. 6 times 4 on the outside is 24. That's it. Now you have time to work on your paper.